Lithium is a chemical element with the symbol Li and atomic number 3. It appears near the top of the periodic table, in group 1, which is known as the alkali metals. These elements share similar chemical behavior, especially their tendency to react easily by losing one electron. Lithium is the first metal in the periodic table and also the lightest solid element under normal conditions. Because of its low atomic mass and simple structure, lithium is often introduced early in chemistry as an example of how atomic structure shapes chemical behavior. The position of lithium in the periodic table explains many of its properties. With just 3 protons in its nucleus and 3 electrons surrounding it, lithium has a very simple electron arrangement. 2 electrons fill the first shell, while the third occupies the outer shell. This single outer electron is only weakly held, making lithium chemically active. However, compared to other alkali metals like sodium or potassium, lithium is slightly less reactive, a detail that becomes important in understanding its chemistry. Lithium was discovered in 1817 by the Swedish chemist Johan August Arfvedson. At the time, scientists were actively analyzing minerals to identify new elements. Arfvedson was studying a mineral called petalite, found on the island of Uto in Sweden. While examining its composition, he noticed the presence of a previously unknown substance. This new element behaved similarly to sodium and potassium, but was clearly different. This marked the first identification of lithium as a distinct element. The name lithium comes from the Greek word lithos, meaning stone. This name was chosen because lithium was discovered in a mineral rather than isolated from plant ash or salt water, as was common for other alkali metals. This origin highlights an important moment in chemistry, when analytical techniques were becoming advanced enough to detect elements present in very small quantities. Pure lithium metal was not isolated until several years later, once methods for separating reactive metals had improved. In its pure form, lithium is a soft, silvery white metal. It can be easily cut with a knife and has a metallic shine when freshly exposed. However, this shine does not last long. When lithium comes into contact with air, it slowly reacts with oxygen and nitrogen, forming a dull surface layer. Because of this, lithium metal is usually stored in environments that limit its exposure to air. Lithium is remarkable for its extremely low density. It is the least dense metal and one of the least dense solid elements. In fact, lithium is so light that it can float on water, although this is not something typically demonstrated outside controlled environments. Its low density comes from the small mass of its atoms and the way they pack together in the solid structure. This property makes lithium especially valuable in applications where weight is an important factor. Chemically, lithium is classified as a highly reactive element. It readily forms compounds by losing its outer electron and becoming a positively charged ion. This lithium ion is small and strongly attracts negative ions, leading to the formation of stable ionic compounds. Lithium reacts with many elements, including oxygen, halogens, and sulfur. Because of this reactivity, lithium is never found as a free metal in nature. Instead, lithium occurs in nature as part of minerals and dissolved salts. Common lithium-containing minerals include spargmine, lepidolite, and petalite. Lithium ions are also found in salt-rich brines, especially in regions where water has evaporated over long periods of time. These natural sources are now the primary way lithium is obtained for industrial use. The extraction of lithium from these materials has become increasingly important in recent decades. One interesting chemical feature of lithium is how it differs slightly from other alkali metals. Although it belongs to the same group as sodium and potassium, lithium often forms compounds that behave more like those of magnesium, a phenomenon known as diagonal similarity. This is due to lithium's small ionic size and relatively high charge density. As a result, some lithium compounds are less soluble in water than expected and have unique thermal properties. Lithium also has several isotopes, but only 2 occur naturally. These are lithium-6 and lithium-7. Lithium-7 is by far the more abundant isotope. The presence of these isotopes has made lithium important in nuclear science, where specific isotopic forms are used for specialized purposes. The study of lithium isotopes has also helped scientists understand processes that occurred in the early universe. One of the most fascinating aspects of lithium is its cosmic origin. Lithium is one of the few elements that were formed shortly after the Big Bang. Along with hydrogen and helium, small amounts of lithium were produced during the earliest moments of the universe. This makes lithium not just a chemical element, but also a record of cosmic history. Studying lithium abundance in stars helps astronomers test models of how the universe evolved. Lithium is found in small quantities throughout the Earth's crust. It is not especially rare, but it is widely dispersed, which makes extraction challenging. Trace amounts of lithium are also present in seawater and in many living organisms. In the human body, lithium is not considered essential in the same way as elements like iron or calcium, but very small amounts are naturally present and can influence biological processes. In medicine, lithium compounds have played an important role for many decades. Certain lithium salts are used to help manage specific mood disorders. In these applications, lithium affects chemical signaling in the brain. This medical use requires careful control of dosage, highlighting how the same element can be both beneficial and harmful depending on how it is used. This balance is a common theme in chemistry. In industry, lithium has become one of the most important elements of the modern world. Its most well-known use is in rechargeable lithium-ion batteries. These batteries are used in smartphones, laptops, tablets, and electric vehicles. Lithium is ideal for batteries because it has a high electrochemical potential and low atomic weight, allowing batteries to store a large amount of energy without being heavy. Lithium batteries have changed how energy is stored and used. They allow portable electronics to be smaller and more powerful. They also play a key role in renewable energy systems, where excess energy from sources like solar and wind can be stored for later use. As societies move toward cleaner energy solutions, the demand for lithium continues to grow. Beyond batteries, lithium compounds are used in many other areas. Lithium oxide and lithium carbonate are used in the production of special types of glass and ceramics. These materials can withstand high temperatures and sudden temperature changes, making them useful in cookware, laboratory equipment, and industrial applications. Lithium-based greases are also used because they remain stable over a wide range of temperatures. Lithium is also important in scientific research. It is used in certain types of alloys to reduce weight and improve strength. In aerospace engineering, even small weight reductions can make a significant difference, and lithium-containing materials help achieve this. In chemistry laboratories, lithium compounds are often used as reagents and standards because their behavior is well understood. Despite its usefulness, lithium presents challenges. Mining and processing lithium must be managed carefully to reduce environmental impact. As demand increases, scientists and engineers are working to improve recycling methods and develop alternative technologies. This reflects a broader effort to use chemical resources responsibly and sustainably. Lithium's simple atomic structure makes it a valuable teaching tool in chemistry. It helps illustrate concepts such as electron configuration, periodic trends, and chemical reactivity. From introductory lessons to advanced research, lithium continues to play a role in helping scientists understand matter at both small and large scales. In summary, lithium is a light, reactive alkali metal with a unique place in chemistry, technology, and the universe itself. It connects the earliest moments of cosmic history with modern devices used every day. Its properties make it both scientifically interesting and practically essential. This combination of simplicity and importance is what makes lithium a truly distinctive element.